So we have here a Stirling engine. A Stirling engine constantly compares the heat that's on the bottom plate, or the temperature of the bottom plate, to the temperature of the top plate. And the more differential there is, the faster this little wheel up here turns. So what I've done is I have put a black stripe on the wheel. You can see it going around occasionally. And that black stripe then creates a differential in reflection, where over here where we have a light transmitter, infrared receiver, so that light bounces differently off the white part of the wheel than it does the black part of the wheel. And from that we can feed that information into the Arduino here, which is tucked underneath that relay, and the Arduino then will do some math and crunch some numbers. It will come out with an RPM value, which it then sends over here to the display, and the Stirling engine is currently at 111 or 12, somewhere in there, RPMs. Not perfectly accurate, but it does a pretty good job. Also, we recently added some code to the Arduino program here that says if the RPM is greater than 100, we're going to turn off the heat source using the output pin. Now, the heat source is this Mr. Coffee heater underneath here, which is heating up a heat sink, which then is transmitting heat to the Stirling engine. What we have is we have the power coming in from the plug into a relay, which the Arduino controls through those statements we just looked at. And we turn that relay on and off, and that relay then feeds the Mr. Coffee, which, as you can see by the indicator light back here, is currently off. So it is now ramping down towards, I think, about 60 RPM. When it gets down to 60 RPM or so, the relay will click back over and it will pick up speed until it gets up to about 100 or so. Somewhere in that area. I forget what the actual number is. Right now it's 109, and it does tend to overshoot because of the heat sinking capacity of that big blue chunk of aluminum under there. So that is our Stirling engine with a rudimentary temperature-based speed control, using an Arduino to determine the speed of rotation, and using that speed to modify the operation of the Stirling engine itself. So that's what we've been up to lately. Should stop by and check out the fun. See you later. Bye.